Hey, what's up, Ziguanas? This is day 8 of the 30 days of Zig Coding Challenge. So for the 8th time, I invite you to join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. So it is day 8 of Zig, and I would say day 3 of playing with pointers because I still haven't finished with pointers. So let's jump right into it. And this is where I stopped last time. So this is the next thing on the menu. Integer point conversion. Let's see what they say, and I will try to zoom in. Yeah, this is like the maximum zoom without losing the content here. Zig supports, no. Jumped back. This is the one. Okay. Convert an integer address into pointer. Use this function. Convert a pointer to an integer. Use this one. Okay, so it works both ways, right? Integer address into pointer to an integer. So integer, but we'll see if it should be addressed. Let's go back here. So these are the things from before. Let me delete those, and let's start from here. Let's have a copy paste everything, and then I'll organize a little bit better. Let's see first what they want to do. So this is a constant. The name is ptr, and it's a pointer to the integer with size of 32 bits. What they do here is they call this function ptr from int, and they provide integer but in hexadecimal form. It'd be okay, 0. Then they create a constant address, and then they invoke this other function. I would actually like to print it out here. So let's try to print first. And I want to say something like pr equals, then inject the ptr, and because it's a pointer, I believe I have to do this here. Format it. And then here it is the opposite. So integer, I believe I don't need to do a starting here. Just use the other constant here and here as well. And let's see what they do next. Okay, I'm not going to try, I will print, but let's see first what they want to do. Type of, they're checking if the type of the address is usize. And they are making it here from pointer to integer. And by default, this will be a usize by 32 or something else, but the architecture dependent unsigned integer. Okay. And then what they do next, they test if the address is equal to the original pointer. Here they have the original pointer from nt, and then they create an address, which is, yeah, so what I guessed at the beginning, it is an address, of course. Okay, let's print this instead of trying to do all these. And let's do this. I don't want to test if it's usize. I want to see what it will tell me that it is. In a similar way, I want to do here. Part here, same thing. Say press equals. Then do the same here. I print, or yeah, I already did that here, so it doesn't matter. Let it run 2 times. And again, I forgot to backslash and everything. For the sake of readability. Okay, let's see. First one, pointer is I32 value at this memory address. What we had here, right? So we say we want to make a pointer out of the integer literal, the hexadecimal literal, and then we convert it to a pointer, and then just get the type and the memory address. Okay, then the next thing here, address. Okay, by default it will be in. So here it will be by default in decimal, not hexadecimal. Here as well, of course, because I did the same thing. But let's try doing the hexadecimal output. Compare them. And yeah, it's of course it's the same. Play a little bit, and then the next thing is we are printing what is the type of the address, and it is usize as expected. And then finally here the address. I can actually do the same thing for the type. See the type of pointer. See it one more time. Yeah, it's a pointer to I32. Okay, makes sense. Yeah, I forgot that this is how you see the value of the pointer. I mean, not the value, so not directly going to the address and then take the value, but the actual pointer, what it contains, and this is type. Okay. Let's see the next one. I will try to wrap it up. I think there are 2 more. They have also these more than 2 alignments. So I will not do this alignment thing. So I just want to finish with pointers. So this one and this one I will do. And then I would like to go actually to slices. I mean, it is related to pointers, these other things, but I don't want to go that deep because they are probably going to mention things that I haven't touched yet, like this thing here. So yeah, I will definitely just do these 2 examples that are left for the conversion, casting these 2, and then I will go through slices. Ranges, I think they're also mentioning them. I don't know if they're a separate topic, I forgot, but I will search them here. And let's see from there what will be next. Okay, so this is finished. Let's see the next one. Zig is able to preserve memory addresses in Comptime code as long as the pointer is never dereferenced. And they do this with this Comptime block of code. Okay, so in some other languages this would be static word. Same thing. So let's do this. Let's copy paste them here. See what they say. Zig is able to do this at compile time as long as pointer is never dereferenced. They create a pointer, this type, y32. They again call the same example, where they make one pointer from the integer hexadecimal literal. Then they create address, the same thing like before. So they convert pointer into address. Then basically they do the same thing. Yeah, I'm not going to run this. It's the same thing. Literally the same example. They didn't do anything different. Okay, it's just like Comptime. Yes, okay. Let's run it at least. And let's then do this instead of this, because it's the same thing and I just already formatted the print. And the only difference is it's now inside of Comptime code block. Say third. I did paste problem, so paste everything. This one. I copied the wrong one. Now we have PTR, now we have address. Value. Okay, this is something deeper. Maybe I just did the referencing that they said that I shouldn't. Okay. Sorry, Travis. Yeah, I've just seen your comment. Let's see what you say. ZigTools is the org who made this. Happy coding. Thanks, Travis. Okay. I will definitely look into it. Yeah, I'm not used to looking at comments because literally like I think you're the third person who commented, so I'm not still expecting some comments, so sorry for that. I mean, third person in total, not today. Okay. So let me just double check if I copy pasted the same thing. Or what did I do? I copy. Let's double check. And I'll just print things here manually. Safer. Make a mistake. Type of. I don't need anything here and here. Same thing. This. And basically. So definitely, because I'm using the pointer, because I'm printing it. I mean, not definitely. Let's try not to print. To this part just to declare them. Yeah, then it say a different error. Constant. Yeah. Okay. Let's see one more time what was the error if I copy pasted, and one more time to check the code. It's the same thing. I just used function here and here. Here, unable to resolve Comptime value. Here, get this. Here, threads. Box wide. This is threading. Now, okay, I will definitely look into this. Spend more time today on this, because I literally copy pasted. I didn't actually. Let's just try one more time, literally to copy paste their example with testing and everything, and then let's see if it's going to make some difference. Not, I will just move on to the next example. I will then off stream try to figure out what happened. Maybe this is because I'm running it online. Okay, doesn't matter. So I'll just leave this and I'll double check later. And let's move on to the next one. And the last one for pointers. Your cast converts a pointer's element type to another. This creates a new pointer that can cause undetectable illegal behavior, depending on the loads and stores that pass through it. Generally, other kinds of type converters are preferable to PTR cast if possible. Okay, so this is like the example what not to do. Right. Let's see. PTR cast, okay, they are using it already here, so I can just copy paste. And I also don't know. I skipped this part. I don't know what it does. It's array. Then we create 32 pointer constant with this function that they recommend. Let's just print it here to see what. Skip this part, so I don't know what this align thing do, but it doesn't matter. These examples and then slices. I mean, there are so many interconnected things, so I have to start from somewhere. And because it's pointer, I guess again start here. Okay, we have U32, this memory address, and then we have like 3 bytes, right? And we have a little bit different function. Okay, and this is a hexadecimal, so let me try to, can I combine these two? Can I use the star and the B? See this in, not B, but the decimal, to see this in decimal. I guess because it's pointer, I cannot, just to see. They will show address in decimal. There is another, I think, doesn't matter. Okay. Yeah, I'm not getting the same. So this is also hexadecimal. I was actually expecting to get this, but for some reason, when I ran the code, it did show a different address here. What else did? I don't import them. It's from std. std as well because I imported it. Okay, just actually print not D. And this is the value, so it's 1. And actually, it's then part value in star. See what they do actually. So they use the standard library, them bytes as slice. Okay, so they convert to slice. I didn't even read what they do. Example is five. There are better ways to do the above than pointer casting. For example, using slice, narrowing cast. Okay. They slice it with 32 slice from the beginning until the end. Then take the first element of that slice. Let's see. This runs. And this is star. As I was realizing this should be star problem. Yeah. And what they expected. So this looks like a decimal, but it could be also hexadecimal, but just like not using the ABC other digits. So they're expecting a different value. I don't know if this would be, in their case, true or false, but in my case, it's not this number. And now actually I'm getting the, okay, this is a decimal one, then definitely let's try to make it X. See what they do. Oh. Okay, now it makes sense. Another way, the straightforward way to do it is this. As here. So let's do that. Here as a folder and again. And now it's here. Here. And leave, I believe, but let's see. The same thing. Okay. 70. So lazy to count 70, but it's somewhere here. Show so here bytes, so maybe I could. Aha. So, yeah, I'm missing one parenthesis here, I believe. Yeah. This one. It here where I do, but here it's important. Where is okay. Okay, so the same number like before, I believe. So if I make it hex, yeah. Okay. The last example, when the types have a child field, tells you the type they point to. Ah, oh, that's cool. Let's do this part as well. Type info, I've also, so a lot of these functions with at that I haven't seen before. So I knew only this one for today. Well, but I any of these others type of okay. But these others are new to me. I'm here, and this time I'll and this to go inside. and it can be just to double check. Okay. Ah, it's a type. Okay, okay, yeah, no, it's not. Yeah. They're not going to say number. It's a type. Yeah. So info. Okay, so I could here just something like this, a variable. Let's do that and work in the same way. This one, so it's a const. 32, it's 32 only, but do it. Be more dynamic than hardcoding. Okay. 32. Because I'm literally putting the pointer here, so it's not, it's type. So I guess I can use type of, where is it? Yeah, I have paste. Lazy. If I do this, work. Yeah. And it's again U32, so it doesn't care that it's a constant. Okay. Okay, that's it. All right, so I would stop with pointers here because a lot of these other things are closely related to some more things that I haven't touched. So let me try to come to slices and let's first of all see how large. Oh, this is large as well. Started now, it's going to stream much better. Then try just ranges at least. So search from the beginning and I say range this. And so they mentioned only here basically. Ranges can be specified using the 3-dot syntax. These are inclusive O10s. Let's try to print this. See what. Print and is equal. So I guess same thing, but just check. Okay, comma here. Let's try comma, but different than what. Try this zig range. So it's 2 dots here. They say 3 dots. They use 3. Two dots. What is the ID version of Zig or something? Switch to three dots doesn't. They two dots, so it's not important what it will be. The same thing. This can be something that AI can help. Other examples here. Drag screen. So say I will take this code that I have here and okay. Okay. Say let's ask. I mean, it could be something that it's hallucinating. Oh, much hassle because I mean, it's interesting, but I don't want time. I'll read this later. What is curly braces, but very weird font. Okay, my original computer. Yeah, like in oh, wait, is the same what I had. Let's see, is something. no, just wants to test this as a string. Language, it's here, it's 04. I mean, yeah, I know that it's not still mature, not hasn't reached version 1.0, so it can be that they changed the rules language so that this doesn't work this version, but I'm reading literally the documentation for 14, 0.14.0, 0.14.1. Maybe it makes, not sure. Okay, anyways, I don't want to do this live and just like stare at the screen without any solution, so I will dig into this and see if I figure out why. But no matter what, tomorrow I will continue with slices. So that's the next thing on the menu. So tomorrow I will do slices and I will try to do this. I will try to find the solution for 3 dots. If someone knows the answer, please write down the comments so that I understand why I couldn't use this example from the official documentation. And that's it. Thank you for today, guys, and see you tomorrow. Have a nice one. Bye bye.